The Center for Geotechnical Modeling is located at UC Davis. The center is operated and managed under the direction of Dan Wilson and Ross Boulanger. The research performed at the center is to advance the ability to predict and improve the performance of soil and soil structure systems affected by earthquake, wave, and storm surge loading. This is done by scaling the stress in a model specimen using the radial G-field produced by a centrifuge. The main equipment at the facility consists of a 9-meter centrifuge shown in the lower left, which has the largest shake table in the world, and a 1-meter centrifuge shown in the lower right, which can be used for pilot studies. Both centrifuges are supported by a large and diverse set of equipment that can be used to build models. The facility is spread across 3 separate buildings, moving from left to right. The prep for the 9 and 1-meter centrifuge is done here, as well as housing of the 1-meter centrifuge. Located in the middle building is electronics and sensor calibration, and then finally over here on the right is a 9-meter centrifuge, which is located beneath the ground. For those of you who have not seen how a centrifuge operates, here is a sketch of the 9-meter centrifuge. The centrifuge rotates around this spindle, which is shown here in the center. As you rotate faster and faster, the bucket starts to tilt up, and when you get to 75 Gs, the bucket is near vertical. The G-field produces a normal stress on your model, and an actuator located down here at the base can simulate shaking of the model and any structures that you may have on top of the model. Here's an example of a recent project that used the 9-meter centrifuge. In this experiment, the system-level performance of building foundations founded on MICP improved zones overlying liquefiable sand deposits was investigated. This experiment was designed to understand the effect MICP had on reducing total and differential settlement. The study did show that MICP had an effect at reducing settlements and damage to buildings. Thank you for your attention. For any additional information about the center, please visit our website, which is shown here below.